All right, so let's take a look at volume expansion. So just as linear expansion occurs in solids, volume expansion occurs in liquids and gases. Right, we take a gas and we heat it up, it expands, we cool it, it contracts. And you've probably seen this in like a soccer ball or a balloon. If you blow up a balloon inside and then you take the balloon outside in the winter, you will see that balloon contract as the temperature goes down. Soccer balls do it as well. Tires do. So if your tires are of a good tire pressure when it's warm, then when it cools, there will be less tire pressure in them because there's a contraction of the gas. Volume expansion depends on change in temperature, original volume, and type of substance. Well, we've seen this formula before. Delta V, that's going to be our change in volume. Again, our units don't matter. Whatever unit we're measuring the volume with. So cubic centimeters or liters, the units don't matter. This is B, this is a beta. It's the second letter of the Greek alphabet. That is our coefficient of volume expansion. Again, it's just a number that you look up on a chart. V sub 0 is our original volume. And our units will match our change in volume. So usually we use liters for this. Delta T again is our change in temperature. And that's in degrees Celsius. Simple. The formula works exactly the same. Our change in volume is equal to our coefficient of volume expansion multiplied by our original volume multiplied by our change in temperature. If we know any one of these, we should be able to figure out, if we know any three of them, we should be able to figure out the fourth one. Okay, so here we go. First question. A gasoline tank in a truck holds 60 liters at 20 degrees Celsius. Now this 60 liters, it has three significant figures in it. Right? The 6 is significant because it's not a 0. A trailing 0 after a decimal is significant. And any zeros between significant figures are significant. So there's three significant figures here. Gasoline tank in a truck holds 60.0 liters at 20 degrees Celsius. This one only has one significant figure. That's it. If the tank is filled to the top and the daytime temperature goes up to 45 degrees Celsius, how much gas will overflow? Well, that is going to be our change in volume. Right? The amount that it changes in volume is the amount that will overflow. Okay, so let's write up our formula. Always write up the formula that we're using first. Change in volume is equal to beta times volume sub 0 delta T. Let's write down what we know from the question. Do we know our change in volume? Nope, that's what we're trying to figure out. That makes this question easy. We just multiply these other three numbers together. Do we know our beta for gas? Well, I got it right here. 9.5 times 10 to the minus 4. So it's 9.5 times 10 to the minus 4. And that has two significant figures. Both the 9 and the 5 are significant. Our original volume is 60.0 liters. That has three significant figures. This number out front is significant, this number behind the decimal is significant, and any zeros between are significant. And our change in temperature, well, we started at 20 and we ended at 45. So to calculate the change in temperature, it's equal to your final temperature minus your initial temperature. So our final temperature is 45 minus 20 is equal to 25 degrees Celsius, and that's positive. This actually has two significant figures in it. So let's write everything into our formula. Change in volume is equal to 0.0095, nope, 3 zeros, 95 times our original volume is 60.0 liters times our 25 degrees Celsius, that's a positive. So our change in volume is equal to 1.425. So 1.425 liters is going to overflow. Now, when we multiply numbers, we always want to take the lowest number of significant figures and have our answer in the lowest number of significant figures. So we want two significant figures, so our change in volume, we should round it to 1.4 liters. There we go. That's how you use the formula. Now, there are some practice questions now for you to figure out this type of thing. And you are going to be asked to do questions where you figure out any variable at all. There are 11 questions. Those 11 questions will be, you need to do them right now. You get help as you need them, figure them out, understand how to do these types of questions. All right, thank you for watching. I'll ask you the lesson recap questions a little bit later.